Hello YouTube viewers, welcome to my channel Science to Technology. In today's show, Rocket Monday, we're going to talk about an Indian startup company, Agnikul. So let's dive right into it. Well, first you have to understand this. Agnikul started in IIT Madras in 2017. Basically, IIT Madras is like Indian MIT, and it has a division that allows new upcomer people to create a company. Basically, lay the good foundation with proper technical guidance and a lot of extra paperwork that they have to do. IIT Madras helps with that. Now, this idea of a company and a corporation started in 2016, but in 2017 they got actual paperwork done. So the company started like incubated in IIT Madras in 2017. Now, this name Agnikul is very interesting because it's going back to India's traditional root of Sanskrit. So the name is a mix of Gurukul and Agni. Gurukul is like our old school systems used to be classified as Gurukul. So Gurukul is there, and Agni means fire. So they combine these two, basically learning by fire kind of scenario. So Agnikul, basically school of fire, if you want to think of it that way. So it's a very interesting name, and they have a lot of investors and partners, and that's the benefit of doing it in a proper reputable company. And one of those puppy is Airbus. So Airbus also has a small division that helps out multiple startups all around the world. So this is one of them, and IIT Madras is a very big known institution, and IIM Ahmedabad, another big institution. So you have a very thick, very big, impressive list of investors and partner. So they are in very solid ground. They are like, they got this. So at least they won't be like, okay, I started, or I don't have any money. They won't have that kind of issue. They got good funding. They got not too much. It's not like they are swimming in money, but they're like in solid grounds. And because of the technical faculty that is available to them, because of their partners, they're in good position. So this Mohin and Srinath, these two people started this whole damn system. Now, what is the philosophy behind it? Now, philosophy is very important because what makes Apple Apple? Because of Apple's philosophy. What makes Sony Sony? It's philosophy. What makes SpaceX SpaceX? Elon Musk's philosophy. Go to Mars. The end. Go to Mars. What made Apollo mission successful? Because of a president's mandate. Get to moon with before this decade is out. Like absolute clear philosophy. So what is this? This team's philosophy, so to say. Now they realize there is a very niche market, basically a gap, giant gap in supply and demand. Is that small satellite needs ride sharing at this point in time when they were starting this company, and right now there are multiple other companies also trying to fill in this blank, so to say. There is like a kind of giant void left in the market because the bigger rockets like Falcon 9, PSLV, GSLV, and other providers like Atlas and ULA and all that jazz, they have big rockets. They got that. Like if you want to launch heavy satellites, you got that. You don't have to worry about it. But here's the most people are not launching geostationary satellite. Only few people do that. On top of that, micro satellites are becoming more and more practical. So we went from CubeSat and NanoSat to being a thing where just try it out, or try a new solar panel out, try a magnet orca out or something like that, to oh no, these are actual tools we use to do earth imaging for Google Earth and things of that nature, like actually making money out of it. People are trying to do radio communication, like open source radio communication using LoRa equipments. So we went from good to have to no, this is the actual market. People are making actual money out of it. So there is a very huge demand there. Like people are like, dude, I can make a CubeSat. Any Tom, Dick and Harry with a good electrical understanding can make that. You are talking about a college or a school, they can easily do that. So there is a lot of people who can do that. But here's the, not most of the people have $1 billion laying in their bank, which is needed for going in a ride sharing with a big rocket. On top of that, even if you can pay the big ride sharing, you have to wait for their slot. Basically, it's like the big best analogy the founders of this team gave was basically current rocket market is like a train. You have to wait for everything to fill up and then they will launch. So what they want to make is basically cab, where they are like, okay, this is your vehicle, you fill it in, go. We don't have to fill in with hundreds of people or hundreds of CubeSat, which ISRO has done. So the idea is very simple. To take the train, make it a smaller variant, and they want to democratize access to space. That's their selling point. Basically, make it easy to go to space. So if college and university can build a satellite, they can actually launch it also. And they have a very huge team, like a diverse group of people. It's not like, oh, one individual or all of them are engineer or all of them are coders. No, they have a very diverse group. That's very good. And the total number of people is 60. Now that may sound small, but here's the SpaceX started very smaller. So that's a very good foundation they have. So what about their rocket? That's the main thing. So their rocket is liquid rocket, which is awesome because again, solid boosters are not that good for anything other than military. So military solid, awesome. Liquid, awesome for everything else. So they're going with liquid, which is awesome, which is RP1 and liquid oxygen, basically like Falcon 9. And they're gonna use an engine which is custom built for them, and it is 3D printed engine. Be mindful, it's like 3D printed engines are not that common. Electron rocket uses that, so it's something similar, and it is 25 kilonewton, which is good for this size of rocket. Now their architecture is two stage, so they have 7 engines in the first stage. So they're gonna have a hexagonal ring of the rockets and central rocket engine. So that's 7 is the main boosters, and then you have one vacuum optimized second stage engine. Now their target, what they are aiming for, is 100 kilogram to 700 kilometer orbit. Now that may sound small, but here's the deal: they are targeting a small market. They are not targeting like geostationary satellite. They are like, dude, small niche, quick turnaround. That's a very important selling point. Quick turnaround. You come to us, we send your rocket, done, game over. It's not like, okay, we're gonna plan ahead like 2-3 years in advance. None of that. That's the whole selling point. And this, because this rocket is using liquid fuel, it is rather compact. It's 18 meter by 1.3 meters. So it's kind of pencil like, but it's compact. Now that rocket is named Agniban. Agniban is basically arrow that is made out of fire. So it's a very high-end weapon in Indian epics. So generally they are launched from a bow. That bow in Sanskrit is classified as Dhanush. So this company is really doing very good in the naming department. So that bow is gonna be a vehicle kind of scenario. Again, right now only CG is available. So the idea is they're gonna have mobile launch platform. Now there is two reasons for that. First, when they were starting, when they were laying down the foundation, ISRO was not that willing to open up their launch areas, because again, ISRO has already taken care of that. Like there is no airplanes going on top of it. They have a clear line of sight to the sea. Everything, like a lot of work goes into making a launch pad. So ISRO has done that, but they were not willing to share it. So they laid the foundation with the idea of like, okay, we're gonna have a mobile launch pad. We're gonna go where it's needed. So not only in India, they can actually go to abroad also and launch it if it calls for it. If they are like somebody from Ireland is like, bro, come here and launch. Like for different reasons, you may want that. They can do that. That's the whole point of having a mobile launch platform. Now I'm like, launching an orbital class rocket, yes, that's ICBM, basically old technology. We used to do that. We no longer do that because our rocket became A, too big, or B, is no longer necessary. So they're going back to the roots, and right now there are many Indian companies that are starting up, and they're all aiming for this mobile launch platform market. So India's gonna go from barely having any launch platform, is like, who cares about launch platform? So that's kind of interesting. So launcher, the Dhanush, is also under construction. Now what we can expect in the future? Well, because the world ended in 2020, so their first launch, their targeting is end of 2022. Now that may come before that, because again, a lot of investors, a lot of money that can push them, allows them to complete their mission much closer to around 2021 end. But again, be mindful, they are very conservative in this. It's like end of 2022. Now be mindful, I like this company, and I really like the idea that they are not that ditching the ISRO's legacy of solid boosters. They're like, no, liquid is the way to go. Awesome, I'm very happy with that. That properly designing the engine rather than buying it from somewhere, which is even more awesome. I'm truly happy with this. But oh my god, they do not know how to do PR. It's like, are you serious? Like really, like this is the best design I could find of their rockets. Means like rocket engines are designed in CAD nowadays, just an all CAD software. Even the free ones have a good rendering option. Why the heck you don't have good renders for it? And here's still, because this is a private company, they have to do it, because ISRO is solid. They don't have to worry about, like, they could have the worst PR out there, it still wouldn't matter, because again, DRDO has to come to ISRO because of national security, and Indian government is not gonna go to abroad for every single launch. So they are safe. This is a private company, they have to attract market, attract buyers, so to say. And not to mention, there are multiple companies like rocket, like there is another company that is also very close to making something exactly like this, and multiple more that are already under construction. So they have to improve their PR department, because many times other small companies that are another kind of startup, they are like, dude, we're gonna launch this service, we're gonna launch satellites for that. Imagine them showing off the idea, hey, we are launching a satellite with SpaceX. That name alone is big enough marketing that they were like, you know what, even if that will take us more time and cost us more money, that marketing would be worth it. So for that reason, many people want a good site where it's like, okay, I understand what you're doing, how you're doing it, what's your approach, like really very like minimal effort kind of websites. They're really not good. So other than that, I'm really happy what they are trying to do. Like their work is ethic is awesome. But they did a basically a fuel injector test in around 2018 September, I think. And here's the Somehow they have a camera that has interlaced video in 2018. How the heck that's even possible? So that's the whole reality. Like, they have to improve their system. They are doing 3D printed rocket engines, and their video is like, are you sure? So, like, they really have to, put it to the next level. So this was my presentation on Agnikul. I hope you liked it, learned from it. In that case, please click the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show me extra disappointment, and please leave a comment because I try to reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.